So for a female, the pathway is basically the same. Notice, hypothalamus, pituitary, but then ovaries instead of testes. And if you read my little statement here, it's very similar to the statement for male reproductive system. Puberty begins, hypothalamus increases production of GnRH. It acts on the anterior pituitary to trigger the secretion of LH and FSH. Exact same thing that happened in a male. Now, in a female, these two act on the ovaries instead of the testes. So remember, we swapped that piece out. And we're going to get two hormones, estrogen and progesterone. And they, in turn, are going to stimulate female secondary sex characteristics and a reproductive cycle. And I said we did the male structures first because it was a simpler setup. And you'll see why if we go to the next slide. This is the first of 3 pictures that explains how hormones work in the female reproductive system. And the reason it's different is that it's not constant day by day. For a male, basically the same thing is happening every day. But for a female, hormones are secreted differently depending on which day of the cycle we are in. So most of the time when you're looking at literature about reproductive cycles, they quote a 28-day cycle, which if you are female, you know is a load of garbage, and nobody has a perfect 28-day cycle. If you do, you are lucky that it's that predictable. I would say there's quite a bit of wiggle room, probably 4 days either way for most people is pretty normal, and that it's not consistent all the time. If it is, fantastic and you are lucky, but for most people, what they show in the book is just like the average. It's not what happens for everybody. Now, this picture says follicular phase. If I could write on the smartboard, I would write that this is the first half of the cycle. So the follicular phase is the first half of the cycle. It's called follicular because follicles are involved, but that's what this picture is showing. Now, at the beginning of the follicular phase, GnRH is stimulated, anterior pituitary releases FSH and LH, and they both stimulate the development of follicles in the ovary. So we saw before Christmas slides of an actual ovary, and you could see the follicles in the ovary. Some of them were large, some of them were small. But FSH and LH will contribute to the development of follicles. Now, in the beginning, it's more FSH than LH, but I'm going to show you a graph in a little bit that will sum that up. In the beginning, we're just getting estrogen. Estrogen is produced by those follicles, and it has negative feedback. Negative feedback on the hypothalamus, like the arrow shows. And then you'll also see a red arrow pointing towards the endometrium, which we know is the inner lining of the uterus. And it's because it causes the arteries to constrict and causes menstruation. So at the very beginning of the cycle, usually for the first 5 to 7 days, that is when a female would menstruate, in other words, have her period, okay? Now, does anyone have questions they want to ask so far? I'm going to say menstruate a bunch today, so I hope you're not feeling uncomfortable. Now, this next picture shows you ovulation. Ovulation happens on day 14. If you have a perfect 28-day cycle. If you don't, it might happen on a different day, but remember, we're basing it off of this. So ovulation is this picture. If we look at the top, hypothalamus is still making GnRH. Anterior pituitary is still making FSH and LH. But the growing follicles produce even more estrogen. So this estrogen we're producing is in greater quantities. And notice how the arrow changed. It's not having negative feedback anymore. It's having positive feedback. Instead of shutting off the pathway, it's producing more. It's going to cause a surge of hormones. So it's stimulating the production of the hormones so that we get even more of them. That stimulation of hormones is what causes the follicle to burst and the egg to be ovulated. It also stimulates the endometrium, and notice the arrow changed color here for me. I know if you have it printed, it's not necessarily in color, but it's not red anymore. It's not causing those arteries to constrict, but rather stimulating the endometrium to thicken. So at the beginning, estrogen's having negative feedback, but then it swaps and starts having this positive feedback effect. Okay, so we've got follicular phase, ovulation, and then we have one more piece that will be the other part of the cycle. Does anyone have a question they want to ask here so far? So then, we look at the last picture. So the other half of the cycle, which if I could write on the smartboard, I would call day 14 to 28, is the luteal phase. So you can see the name up here. If you look, I've got the same basic setup. Hypothalamus is making GnRH. Anterior pituitary is making FSH and LH. Now, let's remind ourselves of the names. FSH is follicle stimulating hormone. Interestingly enough, it was stimulating the follicle to get bigger. Crazy. LH was called luteinizing hormone. And until now, you might have been like, well, that's a dumb name. What does that even mean? Well, once ovulation has happened and the egg has been released, the follicle that's left is now called the corpus luteum. Corpus means body, luteum means yellow. Literally means yellow thing. So the follicle is this yellow thing that's left over called the corpus luteum. LH is the luteinizing hormone, causing things to be yellow hormone. So LH, its name is derived from the fact that once ovulation happens, you get a corpus luteum, which is yellow. Now, once the egg has been ovulated, that corpus luteum, so what's left of the follicle, is producing progesterone and estrogen. And if you look, they're having negative feedback here. Now, for whatever reason, the arrow was still red here. I would switch it to green if I could write on the smartboard. I should probably switch that. But because they're still causing the endometrium to develop, to get thicker, not to constrict. So estrogen and progesterone cause the uterus to become thicker in case the egg gets fertilized and makes its way there. Now, would I ask you to draw all of this from scratch? Certainly not. That's kind of ridiculous. But I like to show you that it's the same pathway the whole time, but we have different amounts or different types of substances being produced that have differing effects depending if we're at the beginning, middle, or end of the cycle. Now, I've explained it, but here it is with words, just so that you have like written words of what is happening. We know that the ovaries contain follicles which contain an egg. You saw the microscope slides of them the week before Christmas. When the follicle reaches maturity, gets big enough, it releases an egg and turns into the corpus luteum, which degenerates. So that is what I just explained. There are two phases. First, the follicular phase. FSH increases from the anterior pituitary, stimulates the maturation of the follicle, which releases mainly estrogen. There's a little bit of progesterone there, like it's not zero, but it's not the main hormone, which is why on the picture it only said estrogen. Now, when estrogen is being secreted, it stimulates, or in high quantities, it stimulates GnRH, which stimulates LH and triggers ovulation. So all of that was on the flow chart, but this is just words writing to explain what happened. This picture down here at the bottom is like a time-lapse picture of an ovary. It's to reflect over the entire 28 days, what would one follicle look like if we took pictures of it every single day. So if I start up here on the top left, that would be like day 1. And then if I advanced, day 1 was over here, and so the follicular phase would be until I got to this point on the bottom right where you can see the egg leaving. That's day 14. So here's day 1, top left. Bottom right where the ovum is coming out, that's day 14. So if you look at the picture of the follicle, it got bigger and bigger and bigger, then it burst. If I continue my time lapse and I follow it along the bottom, day 28 would be the bottom left. Day 14 was when the egg was ovulated. And over the next 14 days, what was left of the follicle, which is the corpus luteum, gets smaller and smaller. Like I said up here, it degenerates, until eventually it's so small that it's not producing hormones anymore. Now, does anyone want to ask any questions so far? Okay. So we've got a follicle that develops because FSH, follicle stimulating hormone, makes it get bigger. It makes estrogen, which causes a surge of LH, which causes ovulation. That's the basic pathway of what's happening. Now that's the beginning of the cycle. Then in the luteal phase, so it's the same picture that it was before, but now we're just continuing on. After the egg has been ovulated, so after the ovum, remember fancy word for egg, ovum, has been released, LH causes the follicle to transform into a yellow body. Corpus luteum literally means body that is yellow. And it secretes mainly progesterone and some estrogen. So it's always producing both of them, but the one that's in greater quantity swaps. In the beginning, it's estrogen. Later on, it's progesterone. These two hormones have negative feedback, so they inhibit the production of FSH and LH. When the yellow body, so that's what I mean by the body, degenerates, the levels of estrogen and progesterone decrease. That means the anterior pituitary can increase its production again. It's not getting negative feedback, and the cycle starts all over again. Now, if the egg is fertilized, which we will discuss in our next lesson, then the structures surrounding the egg maintain the production of estrogen and progesterone. So the body will get a signal that the woman is pregnant, and estrogen and progesterone will continue inhibiting FSH and LH. It's the basic premise of birth control pills. Birth control pills generally have at least progesterone, if not progesterone and estrogen in them, because if a woman were pregnant, those two hormones would remain high. And so the basic premise of a birth control pill is we're tricking the body into thinking that it's pregnant, so it continues to inhibit FSH and LH. No developing follicle, no ovulation, means no baby. Now, does anyone want to ask anything about any of that? Okay, so first 14 days, follicle gets big, then it ovulates. Then over the last 14 days, what was left of the follicle is the corpus luteum, makes hormones. Now that's what's going on in the ovaries. Here's what's going on in the uterus at the same time. If fertilization has taken place, so if the egg is fertilized, then the fertilized egg goes to through the fallopian tubes to the uterus and then implants itself. But otherwise, the endometrium disintegrates. In other words, all of the built up blood vessels that were there to support this potential baby, we don't need them anymore, so they constrict and the lining will be shed. The uterine cycle begins on the first day of menstruation. So the day a girl's period starts is day 1 in all of this counting. That is where day 1 is. What's happening there is that the corpus luteum has totally degenerated, so it's not producing estrogen and progesterone, and so those hormone levels are low. So if I look at this picture down here, it's showing the thickness on the y-axis. So here, on day 1, the uterus lining was pretty thick. But over the first 5 to 7 days, we can see that it decreases. That's the lining of the uterus being shed. That is the girl having her period. Once menstruation has completed, around day 7 here, we'll see that it starts going back up. So the uterus starts to become thicker again. That's because at the same time that this is happening, that follicle in the uterus was getting bigger, starting to make more and more estrogen, starting to cause the uterus to become thicker once again. And then once ovulation occurs, day 14, which is right about here, progesterone has a pretty rapid impact on the thickening of the uterus. So if you think of this picture on the bottom as a thickness scale, day 1, the uterus is thick. Over the first 7 days, it shrinks, builds back up, and then if we notice where the peak is, I'll bring this up again in our lesson tomorrow, but the peak is where if the egg was fertilized, that's the day the egg would implant itself in the uterus. That's the day it would get through the fallopian tubes, be in the uterus, be ready to implant. Like, it works out very nicely, very, very nicely indeed. Does anyone want to ask anything about the uterus? Okay. Now, unlike males where andropause may or may not show symptoms, menopause usually does. It's the end of the menstrual cycle. 50 is the average, but same thing with the duration of the cycle. There's quite a bit of variability. Some people might go through menopause quite a bit earlier, some quite a bit later. It all depends how many eggs she had to ovulate, because that's really what is determining this. Once a woman runs out of eggs, she doesn't have any more follicles that can develop. It causes a huge disruption in the levels of hormones, and it could lead to pretty severe symptoms for some people. You might have heard people talking about mood swings and hot flashes, and it's because instead of hormones going through the cycle that they have been for her whole adult life, now they're gone. There's no follicle making estrogen and progesterone, and that can lead to huge changes in body homeostasis. So therapy that's commonly used is called hormone replacement therapy, essentially taking hormones to replace the ones that are missing to help temper the changes in mood, body temperature, and all sorts of other things. Now, the last thing I want to do is show you graphically what's happening over time. Now, I'm pretty sure I thought ahead, I did. Normally I would draw this, but I know that I can't draw on this smartboard, so I've put a picture of this. But I believe if you printed the notes, there should just be like a blank graph. Am I correct? Yes. Because the idea is, I want you to wrap your head around what's happening in the ovary, what's happening with anterior pituitary and ovarian hormones, and what's happening with the uterus, because they're all happening at the same time. This one includes body temperature, and I don't think I included it on yours, and that's okay, because I didn't mean to, but it was on this picture and it was too hard for me to delete it. So if you look, on the bottom, there's our 0, 14, and 28 day markers. Those are the things you need to recognize. Where's the beginning? Where's the middle? Where's the end? And then we see concurrently, so on day 1, which is right here, what's going on everywhere? On day 14, what's going on everywhere? On day 28, what's going on everywhere? So if you look at the top, there's the ovarian cycle. You can see it's getting bigger. On day 14, it's ovulating. And the corpus luteum degenerates. It actually has another name, corpus albicans, which means white body, but you aren't required to know that name. If I look at the anterior pituitary hormones, the green line is FSH and the blue line is LH. You can see that in the beginning, FSH is a little bit higher, but on day 14 they both spike, with LH spiking the highest. If I look at the ovarian hormones, it says estradiol here. We call it estrogen in our curriculum and notes, but know that I'm talking about the same thing. So this orange line is estrogen. So notice it peaks right before day 14. Progesterone is pretty low until after day 14. And then after day 14, progesterone goes higher than estrogen.
Is this on the printed notes?
No, because the idea was that we draw it in there. So in the printed notes, there's like a blank thing that you fill in. But I'm going to leave this screen up while you're working on stuff so that you can reference it. The last one is the uterine cycle, and this is actually the same as the picture I just showed you, so it would actually be in the printed notes. It shows the uterus being thick at the beginning, shrinking, so menstruation happening, and then getting thicker again until we start the next cycle. Now, I'm going to leave this.